Hey everybody, my name is Ian McLaughlin, and I have a PhD in neuroscience from the University of Pennsylvania. And it's lunchtime, but I do intermittent fasting, and so I don't eat lunch. And so usually I just keep working. But today I figured, since I missed Sunday, that I would jump on sort of like how it used to be in the old days, when it was like randomly in the middle of the day when I was in graduate school. But one thing did happen a couple days ago, or I guess more than a couple days ago, but we found out a couple days ago, which is a member of this community from the early days, from the very beginning, named Hal Sherman, passed away. And I know, I know some people were closer to him than I was, but we had interacted quite a bit over the years, and he was just so supportive and just nice, kind, funny. It's a real loss. It's always a loss when somebody passes away, of course. But he was just one of those people that was just always above and beyond supportive. And so, Hal, you'll be missed, man. What did he scope about? So he didn't really scope himself very much. He was more supportive of other people. And he did seem pretty omnipresent. He had that sort of quality. And so you will be missed, my friend. So do you eat? Yes. Yes, I eat. And I can talk about intermittent fasting a little bit after we're getting a call. Awesome. Right out the gate. Hopefully we connect and everything. Okay, it looks like we're connected, though it sounds like you might be in a wind tunnel. What's your name and where are you coming from? Or where are you calling from?
Hey, how are you doing?
I'm doing well. How are you?
Good. I'm from India.
Oh, did we chat before?
Yeah, I do think so.
Okay, awesome. So from India, what's on your mind?
Have you seen the Starlink launch like 4 hours before?
The Starlink launch?
Yeah, I mean like the SpaceX.
No, I mean I had heard about it, but I didn't know that was happening today. Very cool. Well, did you have any thoughts about it?
Yeah, I've seen that live. Successfully, they deployed another 60 more Starlink satellite on the low Earth orbit.
That's awesome. Yeah, I mean, Elon Musk is sort of notorious for courting a bunch of controversy, right? He's a pretty singular character. But I think it's difficult for somebody to argue that he's not pushing the boundaries of engineering and of science. Perhaps apart from his companies in the sort of the rocket space and the space exploration space, and of course like electric vehicles and batteries and stuff. His company called Neuralink is intriguing, and a couple months, or I guess over a year ago, they did a demonstration of some of the progress that they've been making.
Another company called Boring Company.
And the Boring Company, right? Regardless of what you think, what anybody thinks about Elon Musk, I mean, I think it's pretty undeniable that things are happening that wouldn't have happened had he not allocated his own money and then the money of a bunch of his very, very wealthy friends to these risky endeavors.
Successful entrepreneur in the world.
What's that?
Successful entrepreneur in the world.
Yeah. Well, clearly, yeah, certainly successful. Yeah, man. Any other thoughts?
I'm a very, very biggest fan of Apple.
Okay.
What do you think about, what's your thought about Apple?
Yeah, I mean, I used to be a complete Apple. All my computers and phones were Apple, but I abandoned them maybe 2 years ago just because it seemed like their devices were overpriced for what they were relative to what you could get, via Windows platform or Android. But it looks like their latest computer, I might be getting their latest laptop just because it seems incredibly powerful. But anyways, yeah, thanks for calling in, man. I'll check out that Starlink launch. All right. So I saw that there were. Here we go. Sorry about that, everybody. Workout gives chemicals. That's true. Neurofeedback. We can talk about that if you'd like. Oh, and so about, yes, of course I eat, but I do something called intermittent fasting, which, and I've been doing it now for a couple of years, which is basically where you only consume food in a certain window of time throughout the day. And, there's different sort of levels of stringency. You could eat just between the hours of 6 p.m. to until you go to sleep, right? Or from noon until midnight, right? For me, I usually wait until about 8 p.m. And I'm just eating until I go to sleep. There's a bunch of interesting research. It's still somewhat of a controversial field. Not everybody is on board, and there's definitely a lot of sort of pseudoscience and poorly devised rationales for intermittent fasting, like based off of perceived evolutionary justifications, like humans evolved to only eat in certain ways or certain foods, and the sort of the Paleolithic diet is sometimes sort of bucketed in with intermittent fasting. I think you can put all of that stuff aside. There are some really interesting metabolic effects for intermittent fasting. However, it's also, I think, worth acknowledging that it's not necessarily optimal for everybody, particularly women who are trying to get pregnant. And quite likely some people in general, just it's an unsustainable diet, or it's suboptimal for them. But that's, it's been working for me for a while, and it's probably the only way, given how little physical activity I've been getting. I don't know about you all, but I've been getting over the past year. It's probably the only way that I've not become quite overweight. So, okay. And which carnival gives motivation in life? Chemical gives motivation in life. Okay, so motivation, that's a great topic. So motivation, when you usually, I think when people refer to motivation, I think what they're intending to refer to is like the motivation to do work that isn't necessarily immediately gratifying or immediately rewarding. Gratification is the sort of keyword there, delayed gratification. And so, fundamentally, one way to think about motivation is that it arises from the expectation of some kind of payoff. And it could be literally it could be literally money, but it could also be just the expectation that good things will happen in the future. Things that are, pleasant or good for you will happen if I study for this test, or I prepare for this presentation, or, I do really, excellent, stellar work at work, and potentially I'll get a promotion and get paid more, right? Or it could be like if I learn how to play the guitar and I master the guitar, like girls will like me more, Those are all forms of motivation, right? But they all stem from a sort of central circuit within the brain called the mesocortical limbic dopaminergic circuit. You might have recognized a word there among that sort of word soup, which was dopaminergic. So that refers to dopamine. And so dopamine is very frequently mischaracterized as being the reward neurotransmitter. And it is involved in reward, but it's actually more the expectation of reward. So, to give you a more practical example. So, let's say you're in a casino in Vegas after COVID is over, and, you go up to a roulette wheel and you're about to place a bet. That's when your dopamine is the highest. Actually, it's probably the highest when the casino person spins the roulette wheel, because you expect, you placed a bet, so you expect that you may very well win. Otherwise, why would you place a bet? And so that is likely when your dopamine is at its highest. And then, win or lose, dopamine is almost certainly going to, revert to the mean, or come back to a, pseudo baseline. It may stay elevated, however, if you do win, because of course you have the expectation of, I'm going to, take all these chips, I'm going to cash them out, and I'm going to go buy, a boat or something, if you happen to be quite lucky. But so fundamentally, that is the role that dopamine is playing. And so, and to give you another tangible example, when people take certain substances to sustain motivation or improve motivation, right? The sort of most commonly consumed one would be caffeine. Caffeine does indeed elevate dopamine levels, along with other catecholamine neurotransmitters like epinephrine, norepinephrine. But that is essentially the main reason that people consume caffeine. But then also, drugs that are more sort of targeted for motivation in particular, which would be, drugs like ADHD medications like Adderall or Ritalin, amphetamine or methylphenidate. Both of those drugs, almost the entirety of their pharmacological action, what they do when they get in the brain is they crank up those dopamine levels in the mesocortical limbic dopaminergic circuit. So that same circuit that we talked about in the beginning for motivation. So, motivation is more complicated than that, of course. Memory is going to be involved. Mood, of course, is very centrally involved. But when you're talking about motivation, generally speaking, the thing that's steering that ship is dopamine signaling. Okay, Lady Gaga takes antipsychotics. What is that? Oh, I didn't know that. So antipsychotics, that's a very broad term. It refers, it's almost kind of like a catch-all term, but like antipsychotics refers to, medications that were actually, initially devised or intended to be used to treat psychosis or psychosis-associated conditions. And there's, psychotics, or antipsychotics and atypical antipsychotics, but broadly speaking, relative to antidepressants, let's say, or anti-anxiety medications. Antipsychotics tend to have a fairly broad pharmacological action, meaning they tend to interact with a wider variety of neurotransmitter signaling systems. And so, very frequently, in addition to like, sometimes they'll interact with serotonin signaling, but very frequently they'll interact with the dopamine signaling system. Oftentimes they will interact with, receptors of which you've probably never heard, like the histamine receptor, acetylcholine receptors, like muscarinic receptors. Sometimes they will even interact with what are called ion channels, or voltage dependent sodium channels, things like that. But the point is that they tend to have a very broad pharmacological effect, and importantly, they're not only used for psychosis, right? Even though they're called antipsychotics, they're not necessarily restricted to the use for the treatment of psychosis. So, they can be used for a variety of things. In some cases, and this is pretty controversial, in some cases they're even used to treat like sleeplessness, to treat insomnia, because oftentimes the side effect of antipsychotics is sleepiness. They can make you sort of groggy and sleepy. So generally speaking, if you're trying to understand the pharmacology of an antipsychotic relative to the more sort of widely understood, widely familiar drugs like Prozac, right, fluoxetine, or Effexor, these types of drugs, generally just think these drugs have broader pharmacological action, and they oftentimes interact with pretty much every neurotransmitter signaling system that you can think of, and the whole point is to modify how that signaling is occurring such that a person is far less likely to, experience very dramatic mood swings or psychosis. Okay, so, hello, sir. I have some questions. Awesome. I will do my best. Hi, could you tell me? I struggle to settle down and read. So I assume you're saying you find it difficult to just sit down and read. Frankly, I think that is probably more common these days than it used to be. I suspect if you were to survey, people, let's say above the age of 18, and compare today's cohort to, let's say, 20 years ago, I suspect that more people find it more difficult to sit down for 3 or 4 hours and just read a book, right? And I think that there's some justifiable reasons for that. I think, and it's demonstrated, we all have to work a little bit more now than we used to sustain, a living. But also, there's just a lot more information out there for us. So, I mean, and more sources of information, more sources of stimulation. And so, I don't think there's anything wrong with that. However, I think it is one of those things where if you don't exercise that discipline, that ability to sit down and focus for extended period of time, it'll just become more and more difficult to do that. And so, I'm grateful that I ended up spending a PhD, having to read a lot of stuff. And so I think I still have that muscle. But I guess what I'm trying to say is you're not alone, I suspect. Okay. I have a psychological problem. Okay. You mean workouts? I'm not sure what you mean. Okay, I do gymming. That's what gives me mental stability. Otherwise, I'm restless as hell to read. Oh, interesting. You know what I used to do is when I was actually in college, I would actually study in the gym. So I would get on a treadmill or something, not super high intensity, or I would do, push-ups, or I would climb a rock wall and, rock climbing wall indoors. And I would integrate reading into that activity. For me, and there's this I don't know how old, but this concept that is actually untrue. There's no evidence to support it, but there's this concept that there are different kinds of learners. There are people who, tend to absorb information more effectively if they hear it, or if they read it and see it, or if there's some kinetic activity, if there's movement involved. But however, there have been studies that have performed, big studies that have been performed, that basically indicate that there's no such thing. That, the idea that like teachers have to concern themselves with delivering information in all these different ways in these different mediums is really unsupported by the actual research. But anyways, I did find that it helped me. I did find that, being on a treadmill and, reading through, memorizing the names of genes and stuff like that, super helpful for me. So it might be helpful for you. By the way, it's because in the next few weeks, Periscope is going to be shuttered. There is a new streaming service called haps.tv. You can find a link to it in my profile. If you want to continue interacting live, go check it out. It's a link in my profile. I also have a YouTube channel, youtube.com/anthropoid, where I've talked about a wide variety of topics, everything from a new potential cure for Parkinson's disease, whether or not the Dunning-Kruger effect is real, color perception, the fact that the human sense of smell is almost certainly quite a bit better than you think it is, than we've been sort of led to believe it is. Obviously talked about SARS coronavirus 2, COVID-19, and its effects on the brain, or what we know about it. The relationships between emotion and pain, artificial intelligence, the similarities and differences between food and cocaine. And so you can check that out. YouTube.com/anthropoid. Again, there's a link to that in my profile as well. What's the best way to stop taking benzos? I was on Klonopin. Is my brain damaged? Gypsy Gina. Yeah, really important topic. So just so everybody's on the same page, Gina is referring to a family of drugs called benzodiazepines. And so these are substances that actually used to be prescribed quite a bit more a couple decades ago for pretty much everything under the sun, and particularly for housewives. For a while they were called Mama's Little Helper, or Mommy's Little Helper. And they are very, very useful drugs. They're actually fairly safe drugs, fairly safe when used, as directed, relative to what used to be used for what benzodiazepines were prescribed to treat, which were barbiturates, which are more dangerous sedatives. So benzodiazepines, what they do is they bind to a certain receptor in the brain called the GABA receptor. And GABA is the brain's principal neurotransmitter, principal inhibitory neurotransmitter. And so, when there's GABA binding a GABA receptor, it makes whatever neuron that receptor is on less likely to fire an action potential, less likely to fire an impulse. So I think you said Klonopin, right? So Klonopin is clonazepam. And so there are a bunch of different types of benzodiazepines, but they all fundamentally do the same thing. They all bind what's called the benzodiazepine receptor site, which is it's on the GABA receptor, but it's not where GABA itself binds. So what these drugs do is they make those GABA receptors more sensitive to GABA. So when GABA binds, your brain's own GABA, when it binds its receptor, then the receptor responds even more than it normally would, which then causes, the sort of overall sedation. Benzodiazepines are used for a variety of reasons. They're less frequently prescribed these days because of what we're going to talk about now. So the issues with benzodiazepines are the same as the issues with essentially every sedative drug, which is you develop a substance dependence very rapidly to benzodiazepines. And in some cases, one can develop an addiction. Those aren't the same thing. Substance dependence just refers to what happens in the brain after somebody's been taking a substance for a prolonged period of time, and the brain adapts, right? The brain is always changing. And in this case, it's changing in response to the chronic presence of a specific drug, a benzodiazepine. And how does it adapt? Well, what it does is it can do a variety of things, right? It will do a variety of things. It'll reduce the number of receptors, GABA receptors, that are throughout the brain. It'll change the way the GABA receptor itself responds. And when I'm saying the brain does this, it's not like there's a decision-making event in the brain that causes all these changes to occur. It just sort of happens naturally, automatically. So it's sort of like a heuristic here that the brain does these things. But anyway, so as a result, you can think of it as sort of like a like if you were playing a chord on a piano, right? Let's say a major C chord, right? C major chord. And so you're pressing down these three notes, right? And you're pressing them. But then somebody comes over and starts pressing the note that you were using your thumb to play, right? And so now you're both pressing this note, right? And so eventually you'll be like, I don't need to press this note. So you'll stop pressing it with your thumb because the other person is pressing that note, right? But then what happens when that person leaves? Nobody's pressing that note anymore, right? Same type of thing. And so you lack that note in that major or C major chord, right? Same kind of thing happens in the brain, where what the brain does is, in response to the chronic presence of a drug that's sort of artificially cranking up that GABA activity, is that the brain adapt. It reduces its own endogenous, creation or manifestation of GABA signaling. But then what happens when you stop taking that benzodiazepine, regardless of what kind of benzodiazepine it is, including clonazepam, what happens is that once you stop taking it, there's insufficient GABA activity because the brain has reduced its own GABAergic activity. And so all of a sudden, you don't have nearly enough inhibition, right? And so one way you can think of this is like if you're in a tug of war, right? Every neuron is essentially constantly in a tug of war between excitation, the drive to fire an impulse, and inhibition, the drive to prevent that from happening. And so there's this tug of war that's constantly happening. You take a benzodiazepine and you pull it a little bit further to the inhibition, right? The inhibitory side is winning that tug of war. And then the brain reduces its own, creation of that inhibition. And then so what happens when, all of that inhibitory activity is gone all of a sudden, the excitation side wins very rapidly. And what can happen is people can have seizures, and potentially they can be fatal, and certainly can damage the brain. And so that's a part of the withdrawal syndrome that people experience from benzodiazepines. And it's one of the fairly few drugs where the withdrawal from the drug can actually be life-threatening, right? Essentially, the only other widely consumed drug that with a potentially fatal withdrawal syndrome is alcohol, believe it or not. So both alcohol and benzodiazepines, withdrawal from these substances can cause life-threatening seizures and withdrawal. So all of this to say, if you're interested in reducing or stopping your use of a benzodiazepine, it is pretty critical for you to interact with some kind of a physician. And that's regardless of whether or not you were prescribed the benzodiazepines. If you were prescribed the benzodiazepines, you should have this conversation with your physician. But also if you were taking them, recreationally or whatever, still, the physician is going to put you in jail, right? The physician is interested in preventing that kind of damage that results from withdrawal. And they can prescribe medications that will, first of all, make it less likely that you're going to have seizures and potentially have brain damage, but also will make the withdrawal syndrome less severe, right? It'll be a little bit more tolerable because benzodiazepine withdrawal is extremely aversive. So that is like, if that's your goal, talk to a physician. And part of that process would be weaning off the use of a benzodiazepine. You don't want to go from, let's say, 8 milligrams of Xanax a day to 0, right? That's not how this would go. What the physician will almost certainly do is wean you off, reduce your dose progressively. Any specific type of physician? Well, any physician is better than none, right? So, a GP, a general practitioner, a family medicine, and generally speaking, that should be your point of entry for pretty much all types of medicine, because they will then refer you to another physician, theoretically, and if you have health insurance, and so that will be covered by your health insurance, which is, can be very, very important. But otherwise, there are addiction medicine specialists. And, I'm not implying that you have an addiction, but the point is, these are physicians who have experience and are familiar with the experience of withdrawal, who have the tools and the experience necessary to help you make it through, right? Best of luck. And then your one aspect of your topic was, does long-term use of benzodiazepines, does that induce brain damage? The short answer to that is not really. There's, so long as you didn't overdose or you're not consuming other substances simultaneously, benzodiazepines are fairly safe medications. Now there's a sort of a trickling in of evidence that very long-term use of benzodiazepines can be associated with an increased risk of dementia, but it's only a couple studies, so we're not at the point where we would all say benzodiazepines cause dementia, right? Certainly not the case. I should say certainly we're not at that level of confidence. But apart from that, not really. The only damage is the substance dependence, but that does not arise because neurons have died, right? That's not what's going on. It's just your brain has adapted to the chronic presence of the drug, and so the brain has to readapt to the absence of the drug, and that'll just take some time and some effort. And the best thing, the way forward is to consult with a physician. Really important topic. My grandson has frontal epilepsy. He's 7. Can it be triggered by stress or physical abuse? Yes. so epilepsy is a very complicated condition. It's been studied for a very long time. It's one of those conditions, like schizophrenia, that used to be attributed to, back before the days of certainly neuroscience, but before the days of like evidence-based medicine, it was attributed to things like demonic possession and stuff like that. And so fortunately, we're in an era where we have a better understanding of the biology at play. However, and so it's been studied for a long time. So we do know a fair bit about epilepsy. There, as I'm sure you're quite well aware, there are different forms of epilepsy, right? People can have, epilepsy is a seizure, a recurrent condition where there are recurring seizures, right? And seizures are just like uncontrolled, abnormal rates of neuronal activity that can potentially stay, in very specific spots, called a focal seizure, or they can spread over larger regions of the brain, and those seizures tend to be more disruptive and potentially dangerous. And so a seizure in the frontal regions of the brain will be different from seizures in, temporal regions. Generally speaking, if I remember correctly, epilepsy tends to arise from more like the temporal lobe, particularly, regions in or near the hippocampus, but it can happen anywhere. But anyways, so can it be brought about by stress? Can it be brought about by abuse? Absolutely. But not exclusively. Generally speaking, epilepsy will arise when somebody has inherited some, unique form of a receptor or an ion channel, more commonly an ion channel, that are sort of like the gatekeepers of whether or not a neuron will fire an impulse. And, just some, slightly unique form of that ion channel that then causes that brain, or the neurons that have those ion channels, of the 86 billion neurons that we have, some of them will have this unique ion channel, and it'll render those specific neurons more likely to just enter into a state where they're firing irregularly. And then, by the way, when somebody goes to the hospital for a seizure, guess what medications are almost immediately administered? Benzodiazepines, because priority number one is to stop those seizures. But yeah, so abuse can be associated with it. Damage, like traumatic brain injury, can be associated with epilepsy, or I should say seizures. A variety of things. Sensory experiences, like seeing certain patterns of light flickering. Very, very bright light can bring on a seizure in some folks. But so it'll be different things for different people. I mean, hopefully, I presume, or I assume that your son has a physician. Okay. Do you think there will ever be a cure for cerebral palsy, or like a way to help someone walk? Yeah, absolutely. All of these conditions. I mean, some conditions are more complicated than others, and we understand more about some than others. But all of these conditions, from I almost said Amazon, from Alzheimer's to Parkinson's disease to cancer to cerebral palsy, these don't to epilepsy. These conditions don't arise from from something beyond biology, right? They arise from unique forms of genes that are expressed, that are inherited and expressed, or unique anatomical structures within the brain. And we can understand those things obey the laws of physics, right? They follow the laws of science, right? And so the only thing that's preventing us from having cures for all these conditions is just a deficit of knowledge, right? And among the many things that humans are bad at, right, one of the things we're good at is amassing knowledge and storing it and building on it. So, I'm always an optimist when it comes to any biomedical condition, and that certainly includes cerebral palsy. Okay. Hi, Ian. Just started my first neurolab, studying caffeine's effects on P300 event-related potentials in a go/no-go test. That's awesome, Grace. Very cool. So P300, what Grace is referring to, is a certain EEG signal. It's a certain electrophysiological signal that can be detected using EEG. And EEG is very easy to use. That's awesome. Well, good luck. Man, it's been so long since I've taken those types of courses. But if you're doing in a lab, so you're measuring this in humans. That is awesome. That's better than any lab I led. Okay. Can me having a deviated septum be the reason I get a lot of microsleeps? My brain just shuts down. Oh, that's interesting. A deviated septum. I've never heard of a deviated septum being associated with that. Hey, Helen, good to see you. Fancy seeing you here. A deviate. So for anybody that's not familiar, a septum just refers to essentially like a divider, right? And the one septum with which you're likely familiar is this one, your the septum in your nose. But you have septa all throughout your body. And in fact, I studied a structure in the brain that's called the septum, specifically the medial septum. And it has no similarity to your, the septum in your nose, other than it just divides things. It's just like a structure in between other structures. So a deviated septum is exactly what it sounds like. So the septum, for one reason or another, is off from center. It's actually quite common. But when it comes to microsleeps, I mean, I've never seen a deviated septum being associated with something like that. So when Sir 10,000 refers to a microsleep, what they're suggesting is that, particularly when, and I can sort of see how you're getting there, particularly when people are at a sleep deficit, they're not sleeping enough. I think we have somebody in here who is intimately familiar with not getting enough sleep. The brain will collect on its debt. Right? There's a bunch of interesting things that the brain does automatically when somebody's at a sleep deficit. So, for example, let's just say you're only getting, 2 hours of sleep a night, right? That's not enough sleep for anybody. Or let's say you're never able to enter into what's called REM sleep, right? Rapid eye movement sleep. So as we fall asleep, we sort of progress, we descend through various stages of sleep, which refer to different patterns of brain activity that occur in different sort of distinct phases as we fall asleep, right? You start at stage 1, patterns of brain activity become more sort of regular, a little bit less frequent than they are when you're awake. Stage 2, even less frequent. And then stage 3 and stage 4, and on we go. It's called slow waves activity, right? Where the patterns of brain activity are just slower and slower and more rhythmic. And then all of a sudden you enter into REM sleep. REM sleep, if you measure activity in the brain, it looks a lot more like you're awake. It's not the same. There are some important differences, which I'm happy to talk about, that are associated with lucid dreaming, by the way. But these are completely different patterns of brain activity. And similarly, completely different biological events occur when you're in REM sleep versus slow wave activity sleep. So for example, for men, I guess for women as well, but particularly for men, testosterone release is at its highest when we're in that slow wave activity phase of our sleep, not during REM, right? This is, the deepest part of sleep. Over any 24-hour cycle, that's when you'll have the highest testosterone levels. And so if you don't get that slow wave activity sleep, you're not going to get that spike of testosterone, right? Similarly, other things happen during REM sleep. Different automatic mechanisms in the brain to help, consolidate memory and things like that. And so, but what's interesting is automatically, if somebody isn't getting REM sleep, and this can be done experimentally, you can just always wake somebody up before they hit REM, because you can measure it, right? Measure the brain activity. What'll happen is that the next time somebody goes to sleep, their REM phases of their sleep will dilate. They'll have even more REM sleep than they would have, had they gotten normal patterns of sleep that night before. I would be willing to bet that there's quite a bit more vivid dreams as a result. But similarly, if you're just at a sleep deficit, right? If you're just not getting enough sleep, if you have insomnia or something, what can happen during the day is you can enter into what are called microsleeps, which is basically like the brain is just suddenly falling asleep for seconds, or even less, shorter amounts of time, where there's just this complete radical change in what's going on in the brain, and then radical change back. And it's sort of like just trying to, okay, you don't have $20, all right, I'll take 5 cents. I'll take 5 cents again, 5 cents again. It's like these little sort of tastes of some sleep. And so when you're saying that, can a deviated septum be associated with experiencing microsleeps, I can see where you're going with that, because similarly to, I keep wanting to say sleep aphasia. No, whatever. When people's breathing is obstructed, and gosh, I can't believe I'm forgetting that word. Maybe I'm not getting enough sleep. That can affect their sleep, right? If somebody snores a lot, right, and they're just like, I happen to have some folks on both sides of my family, actually, including my wife's family. Yeah, apnea. Thank you, Helen. Who have some severe sleep apnea. And I've watched in some cases, not like sat there like watching, but I've been around them when they fall asleep, and you can hear they're just like they're not breathing, and it can be alarming, where you're just like sitting there and it's like, this person hasn't taken a breath in 30 seconds, 40 seconds longer, and it's just like, dude, that cannot be good for you. And it's not. It definitely affects your brain. And so, and your sleep, obviously. And so I can see where you're going with the deviated septum, because, of course, that will also obstruct normal breathing. But I suspect that there might be something else going on. You might have sleep apnea on top of the deviated septum, in which case it's more the sleep apnea. But interesting correlation there. That's very creative. Okay, why does insomnia occur? Nothingness, 0. Big topic. So, insomnia is also, it's a broad term that, obviously refers to a sort of sustained sleep deficit. And I remember when I was in high school, like, the cool kids used to all say that they had insomnia. I don't know why. But anyways, the classic cause of insomnia can be anxiety, right? Chronic stress, anxiety. It just becomes very, very difficult for somebody to exit this kind of like, recurrent loop of anxiety, rumination, stress. Depression can be also associated with anxiety. Interestingly, depression can also be associated with, depression can be associated with insomnia. It can also be associated with hypersomnia, where people like sleep for like 12, 13, 14 hours. We're not talking about adolescents who have crazy sleep patterns, right? That would be the sort of like classic, or the way that, a lot of people develop insomnia. But it can also happen for other reasons, right? It can happen because, we all have what's called a chronotype, meaning like we inherited a certain predisposition to being able to fall asleep or being optimally capable of sleeping during certain phases of the day or night, right? Some people, like I'm a night owl, my wife's a night owl, both of my parents are night owls. We would, if we had it our way, we would rather go to sleep at like, midnight and then wake up at, 9 or something, whatever, or even later, like 2 a.m. When I was doing my PhD, all of my best work, my most important work, was done when nobody else was in the lab, and it was like 1 a.m., which is not optimal because we live in a morning person world. But so, I think it's pretty clear that I have a chronotype that's shifted late. Some people have a chronotype that's shifted much earlier. But so as a result, if you're, if let's say you have a night shift, right, or something like that, a lot of interesting research on the potential detrimental effects of night shift. It's called night shift syndrome. But so if you're never capable of sort of satisfying that kind of natural predisposition, that can be associated with insomnia, right? Also, just exposure to a lot of light, at night. So we evolved to be sort of energized when there's a lot of specifically blue light around us, when the sun is high, when the sun is up, right? There's just more blue light available, and then as the sun's setting, there's more red light because the light has to pass through more of the atmosphere. And so it's, the sun is blasting out pretty much all wavelengths. Well, it is blasting out all wavelengths of visible light, but red wavelengths are able to penetrate the atmosphere, more atmosphere. And so as a result, we have more red light later on in the day, in the evening, and less blue light. And that's when we begin to get tired. That's when, our circadian rhythm begins to kick into effect. And then, of course, we all use these devices that put out quite a bit of blue light, particularly late into the night, right? And so some people appear to be quite a bit more sensitive to that. And so if you're, always watching TV or on your computer or on your phone at like, 11:30 p.m. and you need to fall asleep like at 11:35, it'll be just more difficult for you to get there. And so, there's a variety of other things, diet, of course, if some people are very, very sensitive to caffeine. And so you can enter into this sort of like, loop of you're too tired or you're super tired during the day because you didn't get enough sleep because you were consuming caffeine at, 7 p.m. And then, so you have to do it again, right? To just like keep up, right? You're, just consuming more caffeine to sort of stay functional. But then some people are significantly less sensitive to caffeine. Particularly everybody that I know from Italy, like they drink, espressos at like 11 p.m. and it's like, how do you do that? And they just go to sleep right away. It's crazy. But anyway, so, all these things, another thing is when somebody consumes a lot of alcohol before they go to bed. You will fall asleep, you'll lose consciousness, but it's like a diet sleep. It's like sleep deprived of all of its nutrition, right? Because alcohol will, and essentially every psychoactive drug will influence that progression of stage 1, stage 2, stage 3, REM sleep, back to stage 1. It'll influence that progression. And, as we said in the beginning, if you're not getting slow wave activity sleep, if you're not getting REM sleep, that will have inevitable consequences for the efficacy of your sleep. So there's a bunch of different things that can influence one's ability to fall asleep, and then also one's quality of sleep. So yeah, and we can talk about some of the strategies to try and return to something a little bit more functional if you're struggling with that. And also, if you are struggling with that, talk to a physician, right? You can get a sleep study done. They can, identify, hey, what's actually going on. By the way, I have no idea how somebody falls asleep in a sleep study. Like, you're literally sleeping in a bed surrounded by like cameras, and you have all these gizmos on you measuring, your biology. And it's like, I could never in a million years fall asleep there. That would be the problem. I think we discovered it for me, but for other people, it's critical. Okay, so Ian, from Helen, is this a really convoluted way of saying I should get more sleep? Yep, I hear you definitely have always been a night owl. Yeah. I use medical marijuana before bed. Yeah, I've heard that from quite a few people. There's a lot of anecdotal data that suggest that cannabinoids can be very helpful for some people to get sleep. Not just cannabis itself that has all of the dozens, or in some, from the perspective of some chemists, hundreds of cannabinoids in it, not just THC and CBD, but also some people will use CBD and it helps them fall asleep. However, like many drugs, but particularly cannabis, everybody's reaction to cannabis can, there's a wide variety of ways people can react to cannabis. It's not as simple as some other drugs, and that is because the cannabinoid receptor, the receptors in our brain and in our body to which THC, CBD bind, they're both very big receptors. They're G protein coupled receptors, so they're much bigger than, let's say, a nicotine receptor, nicotinic acetylcholine receptor. And so there's just more amino acids that compose this receptor, and as a result, there are more opportunities for there to be slight differences in what that receptor looks like, and how it responds to cannabinoids. But then also there's differences in where certain cannabinoid receptors are, how many of them are. And so, for example, one very interesting thing that I find fascinating about cannabis is that there's a pretty well characterized at this point dynamic where people who consumed cannabis when they were younger, let's say in their 20s or something, they loved it, right? They had a ton of fun, and then for whatever reason they had to stop smoking. And they go 30 years and they never smoke pot, and then whatever, they're in their 60s or something, they're in their mid 60s and they're just taking it easy, and they live in Colorado or Washington or whatever, or now potentially New Jersey. Now New Jersey just passed medical marijuana, or they just passed cannabis legalization essentially. They smoke it and then they have a panic attack, they freak out, right? And and it can be a really severe panic attack. It's not dangerous, don't get me wrong, but it's a panic attack. It's no Swiss picnic. And so it's like, what's the deal? I used to love this stuff. It used to relax me, right? And now I'm like, I can't stop thinking about what, remembering to breathe, And so there's an interesting phenomenon, and it's not, cannabinoid receptors aren't the only one that do this, but they do this, which is, as we get older, the response of cannabinoid receptors changes, after puberty. And so where some of these cannabinoid receptors are in the amygdala. And so so as a result, it's just a different neuronal landscape, different pharmacological landscape when somebody's developed and their cannabinoid receptors have changed, matured, let's call it. And so their response to the same drug is different. Now, of course, as you say, yeah, it depends on the strain. So definitely, there's certainly plenty of evidence to suggest that there's a pretty wide variation or variability in the concentrations of various cannabinoids among different strains. Like indicas, sativas, kaffir stanicas, I don't know if people still use that word, the diesels, the skunks, right? But they're not that radically different, right? They all will have some THC, some will have much lower than others, but some, they all will have CBD. But so in any case, I also suspect part of the problem is that, if you were smoking weed, in the 70s or in the 60s, it's a different drug today, right? Pot growers are so much better at growing pot these days, where, just the potency of, cannabis now is just literally orders of magnitude greater than they were back in the day. And so, you'd have to smoke like 2 joints to get the same effect as just one hit from a joint today. And so I suspect that a lot of folks are just overdosing, not dangerously, right? It's not going to kill them or anything, but overdosing, right? It's an aversive reaction to a substance. And it's not necessarily even a biological phenomenon beyond the fact that they're just consuming too much of the substance, right? I actually missed ditchweed. Yeah, so it's like shake, I think is what it was called in California when I lived there. Yeah, I mean, I heard stories that like people, sort of part of the hippie generation, they would smoke like the leaves of cannabis, right? And maybe use the leaves almost like a tobacco, like cigar, to roll up some of the flowers. And it's like, that's, there's like almost nothing in the leaves. But anyways, yeah. Why do some people dream in color and some don't? Dapix. Dapix is the handle. That's an interesting. Why do some people dream in color and some don't? Well, I mean, so the literal answer would be there's different patterns of activity in the occipital lobe, in the visual cortex, that will arise that will determine whether or not somebody experiences a color perception or doesn't, right? So more tangibly, there are different regions of the parts of the brain that are devoted to vision that are devoted to perceiving color versus perceiving the presence of light versus the presence of certain shapes like straight lines, diagonal lines moving, the shape of a chair, so these are different brain regions, all within the visual cortex or the occipital lobe. And so if somebody's not experiencing color when they're dreaming, it would just be because there's the regions of the brain that are devoted to color perception are bereft of activity. However, when it comes to dreams, you have to be, you always have to take somebody's report of their experience with a grain of salt, because you're in an altered state of consciousness, and it's not like it's extraordinarily difficult to remember a dream with any significant fidelity, and then of course it's also impossible to, for now, it's impossible to know objectively what somebody is actually dreaming, right? Because you can't measure activity in the brain and say like, Ian was dreaming about flying through his college dorm room last night, which I did weirdly, and there's no way for you to know. There have been studies, by the way, you might find this interesting. There have been studies that have basically figured out how to, by measuring brain activity in the visual cortex, right back here in the occipital lobe, they could decipher what somebody was looking at, right? So meaning like, I show you a picture of a puppy, right? And you're looking at a puppy, and I have, a neuroimaging technology of some sort that gives me a sense of what's going on in your occipital lobe, which neurons are firing, when they're firing. And this team was able to use that information to be able to generate, to render an image of what you are looking at. So, and that's a huge milestone. There are many ways that could be used, of course, but one of the ways would be when somebody's dreaming, right? You could decipher, and it's still very primitive, don't get me wrong, but you could decipher those patterns of brain activity and say, this is what Ian was seeing when he was dreaming. And it would probably be even better than what I would remember seeing, right? But so yeah, like, when somebody says, I never experience color when I'm dreaming, what is more accurate likely to say is I don't recall experiencing color while I was dreaming, right? It could very well be the case that they do actually. They just don't recall it. Yeah. As fallible as human memory is, which it is, very fallible, very subject to error prone, human memory when we're sleeping, that is, extra bad, right? And so, yeah. Adam brings up marijuana. It is very dangerous for the brain. So Adam, it really depends on how you define dangerous, right? And so for me, one way you could define dangerous is anything that changes the brain from its natural, state, right? Anything that causes an externally induced change in neurotransmitter receptors, in synaptic, synaptic connectivity, like which neurons are connected to which. Anything that inhibits short-term memory. Cannabis, notoriously does that, etc. Right? If you can characterize anything that does that as dangerous, but then you have to inevitably say that nicotine is dangerous, alcohol is definitely dangerous, caffeine dangerous, right? Because all of these substances do that. So for me, I think the better way to qualify something as being dangerous is if it damages the brain, if it causes neurons to die, right? And so by that standard, cannabis is not dangerous. Cannabis does not kill neurons. There's no evidence that it kills neurons, which would imply that they're generally speaking in the brain, if you lose a neuron, it's gone forever, right? It doesn't come back. There are very select few parts of the brain where what's called neurogenesis, the creation of new neurons, where it does occur, but broadly speaking, it doesn't occur in the adult brain. But so cannabis doesn't cause the loss of neurons. However, it has been shown to change, basically, the brain is always changing, right? And so if somebody if there's a chronic presence of any kind of substance in the brain, it'll influence how the brain is changing. And so there have been studies that have found, altered ratios of white matter volume to gray matter volume, meaning just altered, Sorry, it sounded like somebody was knocking on my window, which would be very impressive. Anyways, so white matter, gray matter. So basically, it's just it seems to have an effect on how connectivity arises, how neurons can generate connections with each other. And so, but again, all drugs do that. All drugs do that. Now, I think it's always important to acknowledge that for some people, a minority of people, but some people, cannabis does seem to be uniquely associated with the conversion to schizophrenia, right? For somebody who's predisposed to schizophrenia or psychosis, cannabis, more so than other drugs. All drugs, again, do this, but cannabis seems uniquely associated to a greater extent with somebody experiencing schizophrenia or developing schizophrenia. And so, again, that's a minority of people, but I think it's important to acknowledge and recognize. Yeah, my wife just asked, was that you banging? No. Anyways, and so, again, that's a minority of people, and we can predict some of those people, right? We can predict based off of SNPs, single nucleotide polymorphisms, right? So just to give you one example, somebody who has a single nucleotide polymorphism, meaning a slight unique variant of the gene that we all have, but yours is slightly unique because you inherited from one or both of your parents, in an enzyme called catechol O-methyltransferase, COMT. If you have a SNP in that gene, you are at increased likelihood of experiencing psychosis from exposure to cannabis. Again, minority of people. The vast, vast, vast majority of people, cannabis is arguably the most benign recreational use substance. Certainly more benign than alcohol, which is legal in most of the world. And less damaging, associated with far, far lower public health burden than tobacco. Certainly, tobacco still, despite the fact that far few people smoked cigarettes these days than did just a couple years ago, it's still one of the leading causes of preventable death. Alcohol, same story. Cannabis is not. It's almost impossible to overdose from to fatally overdose from cannabis. And so, there are still people who are making a living off of a moral panic over cannabis. Specifically, I'll just name him, Alex Berenson. This guy is a pest. He is, now he's turned into a COVID vaccine denier. Shocking, right? But before, his whole thing was cannabis is a threat to our well-being. It's a threat to society. And it's just, it's obnoxious. And he's not a scientist, and he demonstrates that every single time he talks about anything related to science. Did you say COMT? No, I said COMT. Catechol O-methyltransferase. So COMT. I can understand, particularly in your part of the world, how that might have sounded like a slightly different word. Are you at Drexel? No, I did my PhD at the University of Pennsylvania, though I worked with some folks at Drexel, and one of the other fellows, I'm doing a fellowship right now, is from, she's from Temple University. But I think one of them did do her PhD at Drexel. I'm not sure, but I think, yeah, we might have all of the big Philly research institutions represented at my fellowship. Philly took over this fellowship this year. Philly power. Okay. Yes. Ask any witness to to an incident what they saw, and every account will be different. Bad memory, different perceptions. I do overdo the caffeine. To be fair, I should maybe stop slamming the quadruple espressos. Yeah, totally. Same. Another interesting feature of memory is that every time, a memory is a physical thing in the brain, right? It's not necessarily like now, it's not like a hard drive where, on a computer hard drive, if you're storing a picture or storing a video like this, that there's a physical location on the drive, whether you have a solid state drive or, a hard disk drive. There's a physical spot on that drive where those data exist. In the brain, it's not quite that simple, but it does arise from physical phenomena that occur in the brain. Okay, and so what's interesting about human memory is that every time you remember something, let's say in a week from now you recall this conversation about memory, that memory, physically manifests, right? Neurons fire impulses, fire action potentials. Proteins are synthesized, neurotransmitters are released. But what happens as a result is that memory becomes malleable. It becomes subject to change because all of a sudden it's in this state where other neurons can participate and influence that memory. So I could go from wearing, a gray shirt to wearing a blue shirt. Or, I could go from having said comped to another similar word. And so yeah, that's an interesting, unfortunate aspect of human memory. But it also does open the door to potential therapeutic intervention for conditions like post-traumatic stress disorder, right? If you can, for somebody who has PTSD as a function of some traumatic experience, if you can engage that memory and decouple that severe emotional association, that anxiety, that trauma, that emotional association with that memory, if you can decouple those things, that's a great way to treat post-traumatic stress disorder. And as a result, that is one of the main ways that PTSD is psychiatrically or psychologically confronted. Similarly, phobias. So phobias, one of the ways that one can treat a phobia is through exposure therapy. And so what you do, and this is a very straightforward pharmacological strategy. Basically, what you do is you take somebody, let's say they have arachnophobia, they're afraid of spiders, right? Very afraid. I mean, debilitatingly afraid. And what you do is you can, if they go into a physician, the physician prescribes a medication called propranolol. It's a beta blocker. Basically, what it does is it prevents your body from expressing that severe stress anxiety response, and so you don't feel it as much. It's sort of like there's this reciprocal relationship that our brain has with our body where your brain determines that it is time to be anxious, time to be stressed out, and then it causes this huge cascade that influences the rest of the body. You begin sweating. Your blood vessels dilate and constrict in different parts of the body. Your metabolism changes. Your immune system is suppressed. Literally, your bones can become more fragile if it happens chronically, right? And so with propranolol, if somebody has been given that drug, all of a sudden that anxiety response is no longer capable. All those things don't happen. You don't begin sweating. You don't begin, becoming hyperlocomotive. You don't begin shaking, getting jittery. Your blood vessels don't dilate and constrict in different ways. All of that stuff doesn't happen. And so you're holding a spider, and you're still experiencing. You're like, this thing is going to kill me, or whatever it is that people with arachnophobia feel. But they're not experiencing the severity of that emotional response. And so you do that recurrently, and all of a sudden you've decoupled that experience from the emotional experience, and therefore you no longer suffer that phobia. Same sort of strategy when it comes to PTSD in some cases. Okay, it did. Yeah, it did, right? It was kind of creepy. There was a while back, so you can't see it from here, but there's a garage, like a parking garage just behind us that, multiple levels, and on the top it's flat. You can drive up to the top. There's a dude who would go with a drone, and, you can see there's buildings all around here. He'd go with the drone, clearly a nice, like, phantom drone or whatever they're called, the Parrot, has a camera, and he would fly his drone around our building. He's like, dude, that is super creepy. And, like, I don't know if he was, just a photographer or whatever. I mean, you can get beautiful shots of the skyline and stuff like that. But, like, I have a wife with a baby, point your camera somewhere else, dude. So for a moment, that's where my memory went. Like, oh my God, is this guy, is he crashing his drone into my window? Is there a cure for schizophrenia? So the short answer to that question is no. Right now, there's not a cure for schizophrenia. And frankly, our medications for schizophrenia aren't as effective as we would all like for them to be, specifically for certain symptoms of schizophrenia. So you can think of schizophrenia as fundamentally two buckets of symptoms: positive symptoms and negative symptoms. And when I say positive symptoms, I'm not suggesting these are like cool symptoms that you want to have. They're positive. No, they're symptoms, they're acquired symptoms. They're symptoms, new things that you do as a result of, or experience as a result of schizophrenia. So those are like the hallucinations. And then, negative symptoms are like flattened affect, a bunch of different things. So we have fairly good medications for the positive symptoms to treat things like psychosis, but we really don't have very many medications for the negative symptoms. And schizophrenia is a very complicated condition. It's not just like one specific thing is unique and different. And so if you could just target that one thing, then all of a sudden schizophrenia is cured. It's more complicated than that. Oftentimes multiple genes are involved, and they're not the same in everybody. And of course, there's different manifestations of schizophrenia, different levels of severity of schizophrenia. And also, there is an interesting, schizophrenia is you can learn a lot about the brain by learning about schizophrenia. About the brain, its relationship with your genome, behavior, emotion, perception. Neuroscience has learned a lot by working with schizophrenia, people with schizophrenia. So we owe a debt of gratitude to folks who have had to endure schizophrenia. But so like for example, you will find in families who have had one or more people diagnosed with schizophrenia that their relatives will tend to also have an increased incidence of something like schizotypal or schizoaffective disorder, right? Where it's like there's some similarities with schizophrenia, but these aren't as severe. They're not as debilitating. You will also tend to find in families with folks who have been diagnosed with schizophrenia, you'll tend to find similarly unique patterns of thought. Similarly, just unique, esoteric, interest in esoterica, eccentric sort of personalities, and common, unique patterns of thought that are consistent among, creativity certainly, patterns of thought that are shared throughout the rest of the family, even among those who don't have schizophrenia. More concrete thought. That was me. That was not a drone pilot. More concrete patterns of thought. Like for example, one of I remember one of the examples of how to explain concrete thought in folks with schizophrenia is very, very concrete thought, a difficulty to have abstract thoughts. So for example, if you ask somebody with schizophrenia, can I take your picture? A response that they might say would be like, I don't have a picture to give you, right? Which is like, oh no, I mean, can I take a picture of you, right? Things like that. Or like if you ask, I give you, I ask you, what are the similarities between these four things? Oranges, bananas, fruits, oranges, bananas, apples, and grapes, right? They might say they all have vowels in the words, right? Or they're all, exclude bananas, they're all circles, they're all spheres, right? Rather than saying these are all fruit, right? And so, it's just this really interesting, unique cognitive pattern. But so anyways, all this I find schizophrenia so interesting, so I just wanted to explore the topic. But as of now, because of how complicated it is, there is no effective cure for schizophrenia. And also, there's this tendency that I see sometimes in romanticizing schizophrenia, that it's only if you have schizophrenia you must be a brilliant genius, like John Nash. And by and large, schizophrenia is a tragic, debilitating condition. You do the folks who suffer from it no service in romanticizing their suffering. Okay. Does it have anything to do with split personality? Do we misuse that term in everyday use? Schizophrenia? Yes. Not so much anymore, I think. But people might say like, oh, I'm being so schizophrenic today, or like I've had such a schizo day. Like we used to use the term schizo, not really anymore. I can't remember the last time I've heard that term. And basically, what it means is disordered and chaotic. You can understand the relationship there, but schizophrenia is a discrete, specific condition. So is it associated with violence? Very important topic when it comes to mental illness in general, but schizophrenia in particular. There is this perception that people with schizophrenia are dangerous. The short response is no, is that by and large, people with schizophrenia are the victims of violence. Very rarely are they the perpetrators of violence. In some cases, they can be, right? They're like with people in general, right, you will find stories of rather grisly, gruesome, violent acts. But they are the very small minority of people who suffer from this condition. By and large, they are the victims of violence. And also, by and large, they, when it comes to any violence associated with anybody with schizophrenia, it's self-inflicted, right? And so, there's this story, I can't remember where I recall hearing it. I think it must have been in a class of a medical student at a fabulous medical institution, something like Berkeley, right, or Johns Hopkins or something, who had schizophrenia. And one day, he decided that, he was too stressed out, that he was very, very anxious and paranoid. And so as a medical student, he decided that he needed to have an adrenalectomy, to remove his adrenal glands, right? And if you may know where the adrenal glands are. They are essentially right on top of your kidneys. And so you'd have to go in there and remove those adrenal glands. It wouldn't just be like, I'm going to remove my fingernails, right? Which can also happen, by the way. But so he began the procedure on himself. And eventually he had to, obviously went to a physician, or to the hospital, encountered his fellow residents, and his reaction was not, I just severely injured myself, I need some help. His answer was, can you finish this for me? I need to remove my adrenal glands. Could you finish this? And so, it's things like that where, and again, that's just one very specific example. It's not meant to be representative of the entire condition, but it's things like that where, often, or very much more frequently than on others, it's self-inflicted. Why are some age groups more vulnerable? Adolescents. Excellent topic. You're bringing up like all the important things to talk about with schizophrenia. So you are right. Schizophrenia tends to manifest during or just after puberty. And there's a very good reason for that. So first of all, generally speaking, when it comes to schizophrenia, there is some precipitating event, some usually traumatic event that occurs that is severely traumatizing, right? And then all of us, somebody goes from, being predisposed to schizophrenia to now being diagnosable, right? Now having full-blown schizophrenia. And generally speaking, it's very difficult to wind that back, to, put that back in the bottle, without medications and treatments, of course. So why is that? So one of, a lot of things change in our bodies during puberty. I don't have to tell anybody here that. But one of the things that changes in the brain is a process called synaptic pruning, where we have 86 billion neurons. We have hundreds of trillions, quadrillion synaptic connections between them. Each neuron has an average of about 4,000 synaptic connections. Some way more, some far fewer. But, there's a lot of connectivity in the brain, right? And when we're younger, like I have a 2-year-old daughter. When, at her age, she's going to, or soon, she will have way more synaptic connections than I have, or I assume, unless you're about 3 or 4 years old, you have. There's an interesting evolutionary reason for that. We can talk about that if you'd like. But it is, there are two main phases of synaptic pruning where a lot of those synaptic connections are cleaved away, pruned away, just like a topiary, right? And so, the first event is around, 3, 4, 5 years old, but then also the main event is during puberty. And so the thought is, and this applies to other psychiatric and just brain-associated conditions in general, like bipolar disorder, autism, is that because that process of synaptic pruning, the selection process, criteria of which synapses get cleaved away and which are maintained, because that process is regulated by your genetics and by experience, of course, but your genes play a big role. Because of that, if there's a slight difference in the genes that regulate that process, that process will be executed in a different way, right? Different sets of synapses will be pruned away, different sets will be kept, and the result of that in somebody who has schizophrenia seems to be very likely associated with the development of schizophrenia. And because it's such an upstream, it's not like somebody has a quirky receptor, right? It's that this is a very a higher order regulatory mechanism, right? That's determining. My favorite metaphor for this is like, imagine you're on a boat off the coast of California, and you're planning to just go straight across the Pacific Ocean, right, over to, let's say, China. And so, let's say, you start, you have your steering wheel, it's stationary, it's pointed exactly where the boat needs to go, and you just do not deviate from, the steering wheel stays totally, steady.
and you're going straight. And then right as you're, entering into the harbor, you turn the steering wheel like that, right? All of a sudden, the boat will turn, right? But you're already so close to the destination that it's not a huge difference, right? You're basically right there. Maybe you're off course just a little bit, but not much. Compare that to if you were to turn your steering wheel right as you were leaving California. You're going to be veering miles and miles off because it was such an early change. That's what we're talking about when it comes to having a modified process of synaptic pruning, where it's such an early modification, such a fundamental, important modification that it can result in a whole variety of mental illnesses, including schizophrenia, but then also, autism. Not quite accurate to call it a mental illness, but, conditions, unique brain states, and so on. So that is the main theory for why it is that schizophrenia arises, generally speaking, around puberty. But it's not exclusively puberty. At what point would somebody know when to seek a physician, such as yourself, versus a psychiatrist or a psychologist? So I should, make it very clear, pretty blue eyes, that I am a scientist, so I'm not a physician. But basically, if you're in my family, my advice would be, when you feel like something in your life is consistently reducing your quality of life, that you're not able to function in ways that you used to be able to, or in ways that you wish you could. These are things like depression or anxiety. If you used to enjoy being around friends, if you used to derive a lot more pleasure from being around your family or around your children, or and all of a sudden you don't, you've lost that, then that's the time. I was referring to see a like a neuropsychiatrist versus a psychiatrist. I'm not sure. I'm not sure. Well, here's what I would imagine. And just, again, I'm imagining as though you're a member of my family. If there is a psychiatric condition that's arising from a pretty well-established disruption of brain activity, right? Like you've had a traumatic brain injury, or you're having, potentially you're having seizures or something like that. A neuropsychiatrist will be able to deploy, or is trained to deploy, different kinds of tools, but can still prescribe medication. But the thing that ought to determine that is your primary care physician or somebody making the referral. Okay. So, okay. Sorry if this is off topic, Ian, but is there any progress in finding a cure for tinnitus or tinnitus? I always say tinnitus. It's pronounced tinnitus. Haji wins. Yes, the answer to that is yes, for the first time in a very, very long time. There is a device out of a group in Ireland called Linier or Linieri or something like that. Leniere, I think. Linier. And it's very interesting. What happened Sunday? Why weren't you on here then? That's why I'm on here right now. It was my wife's birthday. And in these times, it just felt like we needed, a little bit of normalcy and just a day, everybody together, snuggling and going on walks and playing around. So that's why. Who am I? I'm Ian McLaughlin. I have a PhD in neuroscience from the University of Pennsylvania, and I live in beautiful Philadelphia. So tinnitus. So this device is really interesting. So, for the issue with tinnitus usually is that the specific cells in the ear that are responsible for vibrating and for you being able to register that, this is a different note than this, right? Different tones. Those hair cells break. And the problem with that happening is that they never grow back. So once they're lost forever. And then what can happen with tinnitus is that when those hair cells break, the brain registers that as just a constant stimulation, as though they're just constantly vibrating. And that can be very, very irritating. And pretty much everybody evidently will develop some kind of version of tinnitus, but particularly people who are exposed to loud sounds, work in construction, fire guns, work in landscaping or whatever. But everybody to some extent will develop it. But what's interesting is that what seems to distinguish people who suffer from tinnitus and those who don't is that the people who suffer from tinnitus seem to just pay more attention to it. Right? That, their attention focuses more frequently on that auditory perception, that sound, than people who don't suffer from it. And so this device is essentially devised to distract you, to sort of short circuit the brain to, cause you to not devote, your attention to the tinnitus. it's not actually curing it. Well, it's not actually curing the biological cause of tinnitus, but it is improving your quality of life. And I know that they're interested. They're doing. I don't know where in the world you are. If you're in Ireland, you might be able to just contact them and ask if you can participate. I think they're planning on doing a bigger clinical trial. And I imagine, if they continue, and they've had good results, compelling results, and it's not invasive. You don't have to have surgery or any kind of treatment or anything. So certainly if you're in Ireland, you can contact them. But for me, that is fabulous. There essentially has never been a treatment for tinnitus. But for me, what I'm excited about is the prospect that we will be able to use, stem cell, regenerative medicine, stem cells to regrow those hair cells, so that not only can you, potentially cure the tinnitus, but you can potentially, improve human hearing as we get older. Our hearing degrades as we get older, no matter what. All of our sensory systems do. And so that might be a way to, keep your ears sharp. And then I wouldn't be so afraid of when I listen to music so loud in my headphones. Okay. So you're part of Penn's research team. I'm trying to get a better understanding of what separates. So what separates like a scientist from a physician? So, you wouldn't want to go to a science. So you come to somebody like a scientist to understand something, right? Let's say you've been diagnosed with Alzheimer's disease, right? Oftentimes physicians either don't do a great job of explaining the biology of Alzheimer's, or frankly, it's not really their job to understand the cutting edge research. Their job is to deploy the best treatments we have at our disposal to improve your quality of life. And so, but the job of a scientist is to understand the biology at play, or at least understand what we know about the biology at play, and therefore can sort of illuminate what's going on. And in my experience, that provides people a greater sense of agency. They understand a little bit more about what's going on in their life, what's causing them suffering. And just because it doesn't necessarily lead to a cure for them, in my experience, it can really reduce a lot of the suffering. Have you ever heard of a phenomenon referred to as gang stalking? Yes, gang stalking. So that is so what Pretty Blue Eyes is referring to is a pretty complicated topic, actually. But, ostensibly what it refers to is when somebody is targeted by a group of people, by a gang, right? But it doesn't have to be like a gang, like a drug dealing gang or whatever. Just a group of people who are, cooperating in tormenting somebody. And this does happen, right? This definitely does happen. However, the problem is that people who are predisposed to paranoia can misunderstand, can connect dots where they ought not be connected. A gang. I mean, yeah, like a gang involved in crime. I don't really know what to call it. Like, just referring to like a group of people who are collaborating together. Think of it as like a band stalking or something. So the problem is that, people have different predispositions to paranoid, anxiety, paranoid psychosis. And so somebody can see, can perceive themselves as being persecuted when it's not happening, when it's just not happening. And, it can be, it's sort of like, it's not necessarily paranoid schizophrenia, but it shares a lot of features. It's the kind of thing where it can be extraordinarily difficult to convince somebody that, and the government, that the government isn't collaborating with, your, high school, bullies, or with people at work, to torture you. Like, it can be very difficult to convince somebody who has convinced themselves that they're being tortured. And, it's also, sometimes it is used as a way to explain sources of suffering in their lives, right? And that's the source of suffering can be they haven't achieved what they expected to achieve at a certain point in their life, or they experience anxiety, they experience depression, and as frustrating as it is, there's oftentimes not a satisfying explanation for why this happens to some people and not others. And so this is one of those explanations that is unfalsifiable, right? Where it's just like there's no way for me to prove to you that the CIA, the FBI, the state police, and are collaborating with your business competitors to prevent you from excelling in life, or to prevent you from finding love, right? But the problem with is that sometimes it does happen, right? So my current job, I work as a science advisor to a state government, and like bullying is like it's a form of gang stalking, and it can get of kids. It can get very, very, very brutal and just torturous. And kids have taken their own lives because of this. So it's like it's very difficult when there's a grain of truth to something. Then you're sort of open Pandora's box. It seems like people targeted are drug addicts or people with psych diagnosis. Well, flip that around, right? So let's for a second let's pretend that gang stalking doesn't exist, right? And I just said that it does happen in some cases. Why would it be that a certain cohort of people who perceive themselves as experiencing gang stalking, why would they tend to be people who are diagnosed with psychiatric conditions or people who are addicted to drugs, right? What do those folks have in common? Mental illness, right? And very frequently addiction is a psychiatric condition masquerading as addiction. People are self-medicating for depression or anxiety or past life trauma, etc., right? So generally speaking, addiction is almost like an indirect measure of other psychiatric illnesses. Well, so it's easy to discredit them, but it's also, these are folks who are predisposed to being paranoid, to seeing paranoia or to seeing collaboration where it doesn't actually exist, and so. Again, you just heard me say, like, it happens. There are certainly stories of people being the victims of this kind of coordinated abuse. But there are definitely instances of people who are just mentally ill and are seeing, cooperation or patterns in the world that ought to not be connected. That is a hallmark symptom of psychosis, hallmark symptom of schizophrenia. And, just as we were talking about schizophrenia, these predispositions are not the same in everybody. And so paranoia, humans evolved to be pattern seeking, right? We look for patterns in our environment. We're very, very good at it, but we can make errors sometimes too. And just like every other aspect of human consciousness, it's sort of a spectrum, and there's a spectrum of functional paranoia, right? And beyond that spectrum, it becomes a problem. Under that spectrum, you're not seeing any patterns at all, right? You're not seeing that, every time there's a tree with this shaped leaf, in a couple weeks, it's going to have apples, right? Like, that's a pattern. So when you're, evolving or whatever, when you're a primitive human, you can more easily recognize, like, oh, I got to come back here because there's going to be apples. How to treat it? I'm not an expert in treating it, but some combination of psychological and psychiatric treatment. And so, yeah, of course I agree. It's very easy for our brains to do that. But when there is truth to it, it's hard. 100%. Yeah, I couldn't agree with you more. It's very, very difficult. And that's true for a lot of conspiracy theories. Like the ones that are the most effective have a grain of truth to them. Okay, social media could be a form of mental illness. Well, it certainly can be associated with it. There's no question about that. And speaking of, gang stalking, social media has absolutely exacerbated that specific condition. Have you ever heard of CRISPR for MS? So for anybody that's unfamiliar, CRISPR is CRISPR-Cas9. It is a technology that essentially enables us to almost surgically alter genes. They don't have to be in the genome, but just genes in general. And so, for example, for my research, we used CRISPR to generate a transgenic mouse that had a unique brain, right? It's very effective, very precise. We had been able, before CRISPR-Cas9, we had been able to modify the genome of various organisms, but it was very untargeted. It wasn't like, well, relative to CRISPR, it wasn't like, I'm going to go in and literally just change these 5 nucleotides, these 5 A, T, C's, and G's, right? So that's what CRISPR is. One of the people who invented it, Jennifer Doudna, won a Nobel Prize for CRISPR-Cas9. I think last year. One of my good friends from my PhD is now working in her lab, which is pretty cool. Enrique Lin Xiao. So is it safe? So is CRISPR-Cas9 safe? It's hey, hello, Dumonu 2. Is it safe? So theoretically, yes. Theoretically, it can be safe. I could use a new brain. Yeah, me too. Theoretically, it's safe because it can be very precise. But it is not ready for prime time yet. So have I heard it for MS? I could see it being used for MS, yes. Don't they use CRISPR for designer babies? So no, not in the United States. It's illegal to do that in the United States. Hey, Danny. And I should just say, I read briefly somebody talking about HAPS. After Periscope is shuttered, I'm going to be focusing my live interactions on haps.tv. It's a different app. And I have a link to it on my profile page here on Periscope, so you can go check it out if you'd like. I'm also on YouTube, youtube.com/anthropoid. Slightly different kind of thing that I do on YouTube, but you can check it out. Link there too. Happy.tv. Maybe they should have gone with that. So it's HAPPS.tv. Yes, thank you. So is it safe? So the reason that CRISPR-Cas9 isn't ready to be, and designer babies also. So in the United States, it's illegal to use it for embryos that are intended to become babies, right? There was a story, and we're still not 100% sure that it's true, although the person who did it was arrested. There's a story in China of a physician using it to treat inherited HIV, which is strange. Like, it's of the various conditions that you might want to target with CRISPR, HIV is a strange one to do. But in any case, there's a story that he did it on twins, and they were born. And the last I heard, I haven't heard anything about the babies, but the last I heard, he was arrested by the Chinese government. But the point is, it's illegal. But so the reason it's not ready for prime time to be deployed as a treatment is that we don't understand the human genome sufficiently yet, meaning we don't understand the function of human genes enough yet. And so as a result, and so let me give you a more tangible example. Let's say you have a gene for a dopamine receptor, okay? And we know that certain versions of the dopamine receptor are associated with an increased likelihood of ADHD, an increased risk of addiction. And so, one might say, hey, if we know that, then why don't we just go in, to my embryo's genome, and let's just modify that gene. So funny, we never heard from the head transplant guy. No kidding, Daryl. Good to see you, by the way, man. So the problem with that is that the genome isn't that simple. So genes, while you can have a dopamine receptor gene right here, you can have a gene for your hair color here, you can have a gene for whether or not your septum is going to be deviated here, all next to each other. They don't really influence each other down the line, but they can influence how each other is expressed, right? So if you modify this dopamine receptor, then all of a sudden you're going to modify the expression of another gene. And you had no idea that would happen because you wouldn't think that dopamine receptor would have influenced the expression of your immune system, right? Or some cell in your immune system, right? And they can do that through a bunch of different mechanisms. They can literally physically interact with each other, like in physical space, but they can also influence the expression of each other by more indirect mechanisms. But anyways, the point being that our knowledge of genetics isn't sophisticated enough, isn't mature enough to be deployed as a medical treatment yet. But theoretically, it's going to be a game changer, right? It will be a game changer. And certainly for conditions like MS, where there's a genetic basis for the condition, so yeah. In fact, I could imagine it being particularly beneficial for a condition like MS, where theoretically you wouldn't have to alter the germline, right? You wouldn't have to predict if somebody's likely to develop MS and then modify their genome while they're still like a developing embryo or whatever. you could just go into those, whatever it is, germinal centers or the thymus. I don't know what kind of cells are responsible for the autoimmunity. But so theoretically, you could just go in and modify those cells. It's interesting. I would have to think about that more. But anyways, theoretically, but just not today. As far as I'm aware, not today. And it'll be certainly used for other conditions like muscular dystrophy, Rett syndrome, RETT, a variety of conditions where there's like a pretty well-established genetic basis. Is HAPS copyright free? Downloaded it, but I haven't used it. Yes. So HAPS is totally free. And frankly, it has more tools than Periscope ever did in its years of existence. And I've had the opportunity to interact with the team that runs it and the founders, and they have just a great philosophy. They have a background in journalism, so they're not sort of coming from that kind of standard Silicon Valley kind of milieu. And they have a great philosophy, so I would highly recommend it. Do you know if the first vaccine shot causes blood clots? You mean like the first COVID-19 vaccine? I have not seen any evidence that it does that. No, and I don't know which specific one, but I haven't seen it for any of the vaccines that have undergone clinical trials as of yet. However, what we do know is that SARS coronavirus 2 can cause blood clots. That was one of the in the early days there was a group out of China in Wuhan who were adamant that what COVID-19 is a blood disorder. Is that it interacts with the cells that compose your blood vessels and causes irregular, like platelets to interact with each other and causes clotting, which then causes all the weirdness that we've seen. Strokes. We've seen strokes associated with COVID-19. We've seen COVID toes. I don't know if you've seen that. Irregular sort of almost like bruising in the toes. So we understand part of how that works, like why it would be that that SARS coronavirus 2 does this. But if somebody is having a blood clot out of nowhere, and they just got vaccinated, I would be more interested. Just got vaccinated, they haven't had both vaccines and they just got vaccinated like the day before. I would be more predisposed to thinking that they actually unfortunately caught COVID-19 before they developed antibodies to it. Okay. Is the mRNA vaccines and the J&J vaccines equally effective? For all intents and purposes, yes. I mean, there are some slight differences, but the problem with comparing them, it's a little bit of an apples and oranges situation because the mRNA vaccines were developed much, much earlier. Well, I mean, they were tested. They underwent clinical trials much earlier than the J&J vaccine. These are different kinds of vaccines, so it's totally a good, you're thinking along the right lines in that, the mRNA vaccines are distinct from the J&J vaccines, which is a modified adenovector, a modified adenovirus, which is the same as the, not the same exact virus, but same strategy as the Oxford AstraZeneca vaccine. It is also an adenovirus. The mRNA vaccines function differently, but fundamentally they accomplish the same thing, which is to have your cells churn out some of that spike protein so that then your immune system recognizes this thing that's not supposed to be there and generates antibodies against it and recognizes SARS coronavirus 2 viral particles before they can proliferate. But the reason it's a little bit apples and oranges isn't just because of that, but also because the J&J vaccine clinical trial was performed when we knew that we had a bunch of other variants of SARS coronavirus 2. We had the UK variant, we had the South Africa variant, and fortunately, and we know that it's quite likely that all these vaccines are still quite effective against them. But they're quite likely a little bit less effective than they were against, let's say, the original variant, OG SARS-CoV-2. And so it's all this to say, if you were comparing apples and apples and they were tested at the same time, it seems like they would have been pretty much equivalently effective. And by the way, the other difference is that the J&J vaccine is only one shot, which is very, very helpful, because then you don't have to coordinate two. But who knows if you were to get a booster dose of the J&J vaccine, it might be like ridiculously effective, right? But they are all ridiculously effective, and I will get any vaccine, no matter what. Whichever is available, I'll do it in a house. I'll do it with a mouse. I'll do it. I'll take it from Faust. I can't rhyme anything else with house. I will do it in a joust. All right, I should probably call it a day. You're supposed to get the second shot on April 2nd. That's awesome. Congratulations. My parents I'm pretty sure they got their second one. Like I literally teared up when I heard about it. It's I can't wait until we can get ours. I just can't wait until my wife and I can get vaccinated. It'll be like one of the few times where an existential dread is relieved. And I don't think you get to experience that very frequently as an adult. Okay. I meant Moderna vaccine twice. Could it hurt? Sir Kent Norton. What about a person takes the Moderna vax first? Oh, well, the Moderna vaccine is taken twice. So the Moderna vaccine is you get a first shot and a second shot. Same goes for the Pfizer BioNTech vaccine, 2 shots. I believe Oxford AstraZeneca is also 2 shots. Yeah, it is 2 shots. Although the UK has what I think is a better strategy right now, which is just get people the shots. And we'll worry about how long we wait until the second shot later. Just get people the shots. Because we know that there's protection that's afforded us after just 1 shot. It's better than nothing, right? Particularly given the spread of the B.1.1.7 variant in the UK. But I also believe that the Sputnik vaccine is 2 shots. It's also a modified adenovirus. But what's interesting about their strategy is that it's 2 different adenoviruses, which I think is quite brilliant. It totally makes sense. It was sort of a question as to whether or not it would work, though. But anyways, yeah, no, there's no harm at all. And then somebody brought up Clubhouse. I am on Clubhouse. I've only used it 1 time. So I think I'm anthropoid on Clubhouse. But I should call it a day. So I have a YouTube channel, youtube.com/anthropoid, where I talk about specific topics, everything from what part of the brain creates habits, can artificial intelligence cure diseases, new strategies to treat addiction, microdosing with psychedelics, a cure for tinnitus, metformin and cognitive impairment and longevity, how do we perceive time, COVID-19 effects on the brain. I don't know if I just said that. Why human brains are different and still smarter than computers. When did humans start reading and writing? How did that even happen? We weren't reading and writing hundreds of thousands of years ago. So when and why did that happen? So you can check that out, youtube.com/anthropoid. I have a link to it in my bio. And then also, I've been using a new live streaming platform that I think everybody will really dig. It's a great community, great tools, called haps.tv, HAPPS.tv. I have a link to that in my profile on Periscope as well. Otherwise, I will have a great rest of your week, and I will see you, hopefully, on Sunday. See you, everybody. All right, everybody on YouTube, thank you so much for joining. I know it's sort of a weird time of day, but if you dug it, if you dug this sort of impromptu chat and you haven't, maybe you'll consider subscribing. I think what I'm going to talk about on Sunday, I already know what I'm going to talk about. And it is, I forgot which one. It's how important facial perception is and how it plays a role in how we interact with each other. And I'm going to talk about some really some old school, really interesting explanations for why it is that humans are so much more cooperative and deceitful than other primates. But anyways, that'll be on Sunday. If you have any suggestions, I'm all eyeballs, open to suggestions. And if you haven't subscribed, maybe you'll consider subscribing. Otherwise, I will see you on Sunday. See you, everybody.